Let's go through code 719. Find the k smallest pair distance. For this question, to give us integer array nums, and let's find the k smallest distance among all pairs. So you say that for the pair I and j, they have different indexes. The distance is the absolute value of those num I and num j. We want to find the k smallest. We have time the n 10 to the power 4th time range. So we should be looking for O n log n or bigger time complexity approach. And we'll say k is smaller or equal to n multiplied this kind of number, right? So that means we always have values. So we know if we want to do some n log n, there is some kind of thing like, for example, sorting or binary search, right? Actually, for this question, we'll say, if we array is already sorted, we know the distance of any pair, well, the largest distance will be at most n numbers, n minus 1 minus numbers 0, right? And the smallest pair distance may be 0, right? So what we think about, maybe we can go to some kind of, it has some kind of bond here, and we can do some kind of binary search approach here, right? So we binary search on the pair distance. So this will be the start. This will be the end, right? So the mid, if we find the mid, right? So what will be the binary search algorithm, right? Is that we count how many pairs smaller equal to this mid, right? So if the counts is greater than k, that means this mid is not big enough. So we should move our left pointer to mid, right? Searching in this area. If it is the counts smaller equal to is smaller than k, right? That means this mid is not big enough. We should search in this area. If this is greater equal to that, we have too many in this, right? So we should have end to here, right? And how do we count how many pairs smaller equal to target number, right? If the nums already been sorted, right? It's already sorted, and we count. We can use the 2 pointer to count, right? So we move the right pointer, and if the right pointer and trying to do the while the nums right minus the nums left is greater than target, right? We moving keep moving the left pointer after we jumping out of this while loop, right? So we know and those kind of left to right, right? And then in any pairs from left to right minus 1, where can be form a pair which is the smaller equal to target, right? So our result will be actually that is the right minus 1 minus left plus 1, right? So that will be right minus left. So that is a count function. After doing this kind of analysis, let's write code, right? So int n equals nums dot length, and let's sort the array. And what we do is that we know the pair we are binary search in the result, so we know the pair case distance, the left it cannot be small equal to 0 and it cannot greater equal to nums n minus 1 minus nums 0, right? So what we write is while start plus 1 small end, and we have intermediate equals start yeah, start plus and minus start divided to, right? So we need to have a count function. If count this numbers, the target is made. If this count is smaller than k, right, that means we don't have this mid is not big enough. We should move our left, right? We should have start equals mid. Otherwise, we'll have end equals to mid, right? In the end, what we do is that if count nums left is already greater or equal to k, right? Return start. Start. Otherwise, return. Right? And we need to have a help function to count. So this array is already sorted, right? And we need to have a target. So that is a count how many pairs. Count a pair number smaller equal to target, right? So we'll have int count equals 0 and left equals to 0, right? For int right, let's have n equals num start length, n equals num start length. For right equals 0, right smaller than n, right? Right plus. So we know we'll say while nums right minus, well, let's say this left should always be smaller than right, right? And nums actually this if we don't have this I think should still be fine, right? Because if left move to the right, the same position, it will be 0, right? So if we don't have this, it still be fine. Nums left greater than target, right? Then we'll have left plus. And we'll say we don't have this, should be fine. Let's remove this. So our result, right? Result or count should plus equal to right minus left. Right? So this is because left, not left to right can form a pair. Right? Left from can come from left to right minus 1, right? So that is right minus 1 minus left plus 1, right? And return result. Return count, right? Okay. Let's write the Python code for this. So let's have this nums sort, right? Sort. And let's have n start n equals length nums and start equals 0 and equals, so we can use -1, right? Or n -1, whatever. And we'll say while start plus 1 smaller than end, mid equals start plus end divided by 2, right? And if count nums mid smaller than k, right? Then we'll have start equals mid. Then else we'll have end. Else we'll have end equals mid, right? And when we jump in this while loop, we'll say if count nums start greater equal to K, right? Return start. Otherwise, we just return end, right? And we need to have a diff count function, right? So we have nums, this list, right? And we need to have a target. This is an int. Also, it goes to int, right? So the count is 2 pointers, right? So because it's already been sorted, we have n count left n equals length nums, and the count equals 0, left equal to 0. And for right in range n, right? And we say while nums right minus nums left greater than target, right? So we'll have left plus equal to 1. And after we jump in this while loop, we'll have count plus equal to right minus left, and return count, right? If count this one start, and if count nums mid start and should not be minus 1, right? And should be it's already been sorted. Let's have this. It's not should it's it is not this, right? So our start is 0, and our be nums let's have this coming out because we defined this. Have start equals 0, and equals nums n minus 1 minus nums 0, right? This is our binary search range. The time complexity is n log n. There is a sort, right? And also the binary search. And so it's n log n.